This is Notes 3-6, Simplifying Square Roots, Day 2. Review from yesterday. Simplify the following square roots by using any method. 6 square root 108. 108 is an even number, so it's divisible by 2. 2 times 54 makes 108. 54 is even. 2 times 27 makes 54. 27 is 3 times 9. I can see here that I have a pair of 2's. That goes outside my house. The square root of 9 is 3. That's a perfect square. And this sad 3 is left over. He stays inside the radical. Don't forget to carry down the 6 that was in front. 6 times 2 times 3 is 36. Square root 3. Okay, looking at the next one. 208. 208 is divisible by 4. In my calculator, if I do 208 divided by 4, I get 52. 52, I think, is also divisible by 4. 52 divided by 4 is 13. And look, I know that 4 is not prime, but it is a perfect, or it is already a pair. I have a pair of 4's. So I'm going to put my 4 outside my radical. 13 is prime. It can't be broken up more. So I'm going to leave him inside my radical. 4 square root of 13 is my final simplified answer. 3 square root of 245,000. This is a big number, but I'm going to try 100 since it ends in 2 zeros. 245,000 divided by 100 gives me 2,450. Okay, 2,450. I'm going to divide this by, it ends in 50, so let's do 50. This gives me 49. Notice here already, I have a few perfect squares. The square root of 100 is 10. The square root of 49 is 7. Okay, 50 is 2 times 25. And I see another perfect square. The square root of 25 is 5. 2 is left over. It stays inside the radical. And don't forget to bring down the number that was in front. If I multiply my numbers outside the radical, 3 times 10 times 7 times 5 in my calculator, I get 1,050, and I keep the square root 2. Okay, number 6, 188. I know this is an even number, so it's definitely divisible by 2. 188 divided by 2 is 94. 94 is another even number, so it's definitely divisible by 2. 2 times 47 makes 94. And 47 is prime. So I see I have a pair of 2's outside my radical. 47 is lonely. He stays in the house. 2 root 47 is my final answer. Convert the following to radical form and simplify. We converted to radical form a few days ago. Now we are going to combine this with simplifying. Remember that my denominator goes with my radical, square root of 12, and my numerator stays the exponent to the third power. 12 to the third power means 12 times 12 times 12. Notice here, I already have a pair of 12's. so that goes outside of my radical. In this third 12, I can break this up. 12 I know is 4 times 3. Oh, and 4, that's a perfect square. The square root of 4 is 2. And my 3 is lonely, stays inside the radical. 12 times 2 is 24, and I keep my root 3. 24 root 3 is my final simplified answer. 147 to the power of 1/2. The denominator is my index, so square root. Oh, what just happened? Of 147. The numerator is my exponent. So the first power just means I have 147 written once. Okay, 147 is not even, so it can't be divided by 2. So let's try 3. If I do 147 divided by 3 in my calculator, I get 49. So 147 is divisible by 3. Oh, 49. I know that's a perfect square. The square root of 49 is 7. My lonely 3 stays inside the radical. So 147 to the power of 1/2, or the square root of 147, can be simplified to 7 square root of 3. Okay, now let's do it the other way around. Number 9, I have the cubed root of g times n to the 7th power. Okay, if I write this in exponential form, it's already in radical form, I'm going to have g times n to the 7th power, and remember the index becomes my denominator. So my simplified answer is g times n to the power of 7 over 3. Using the power of products, I could distribute this to all the exponents inside my parentheses. So I would have g to the 7 over 3 times n to the 7 over 3. Number 10, I have the 4th root of 5 times x. So I have 5 times x to the 1st power. Those parentheses are very important. Remember that my index becomes the denominator. 5 times x, the whole thing, is raised to the power of 1/4. I can use the product of powers to distribute this to all my exponents inside. So I get 5 to the power of 1/4 and x to the power of 1/4. Okay, a little more review. We're going to simplify these using number by number and letter by letter. So number by number, I have 12 over 16. Letter by letter, remember product of powers on top, m to the 3rd power to the power of -8. 3 times -8 is -24. And on the bottom I have -20. Number by number, 12 over 16 reduces to 3 over 4. Remember, when I have division, this means I need to subtract my exponent. So -24 minus -20 gives me -4. So m to the power of -4. In our final answer, we don't want negative exponents. So my m to the -4, his negative is sad. He has to move down to the bottom. So I'm left with 3 over 4. My m to the -4 moves down and becomes positive. 3 over 4 m to the 4th power is my simplified answer. Number 12, number by number, letter by letter. If I'm looking first at just my numbers, I have 3 times 10 over 5. I see the letter A, so I have a to the 4th and a to the 8th squared. Product of powers, I multiply these. This gives me a to the 16th. Okay, and then I have b's. I see b to the 6th. On the bottom, I have b -7 and b to the 3rd. Starting with my numbers, 3 times 10 is 30, divided by 5 gives me 6. A to the 4th times a to the 16th. Remember, when I'm multiplying, I'm adding my exponents. 4 plus 16 is 20, so a to the 20th power. Okay, my b's I'm going to break up into a few different pieces. First, I'm going to do the bottom. So I'm going to leave my b to the 6th. When I'm multiplying, I add these exponents. Negative 7 plus 3 is negative 4. Okay, I can simplify these more. I have 6 a to the 20th. Now I have division. Division means I'm subtracting these exponents. 6 minus negative 4 gives me b to the power of 10. So my final answer is 6a to the 20th, b to the power of 10. Okay, number 13. This time I have a fractional exponent. I'm going to start by distributing it to every exponent on the inside. Remember, this 81 really has an exponent of 1. So 81 to the power of 1/2. K to the power of 16 times 1/2. 16 times 1/2 is 8. And z squared times 1/2. 2 times 1/2 is 1. So z to the first power. And remember, I don't really need that 1. Okay, 81 to the power of 1/2 really means the square root of 81 to the first power. And the square root of 81, that's a perfect square, is 9. I carry down my k to the 8th and z. Notice I have no letters that match, so this is my final simplified answer. Last one, number 14. Okay, I'm going to start with the parentheses. I'm going to put an exponent on everything inside my parentheses. And remember, product of powers, I'm distributing my outside exponent to all of the exponents inside. 1 times 2 gives me 2. 1 times 2 is 2, so 2 to the second power. 1 times 2 is 2, so n to the second power. And n to the 1/2. 1/2 times 2 is 1, so n to the first power. My second set of parentheses, I'm distributing a negative 4. 1 times negative 4 is negative 4, so 3 to the negative 4. And 2 times negative 4 is negative 8, n to the power of negative 8. Okay, number by number, letter by letter. I have 2 squared and 3 to the negative 4th. My m's, I have m squared, m to the negative 8, and n to the first power. 2 squared is 4. 3 to the negative 4. Negative, it's sad, it's got to move to the bottom. So 3 to the 4th power. Remember, when I'm multiplying, I add those exponents. 2 plus negative 8 is negative 6. Then I have times n to the first power. 3 to the 4th power is 81. My m to the negative 6, negative has to be moved to the bottom. M to the 6th. And my n can stay where it is. So my final answer is 4 times n over 81 m to the 6th.